Okay, welcome. So what we're doing here is we're having a look at levers. We've already had a look at the different classes of levers. So we had class 1, 2 and 3. So remember FRE 1, 2, 3. Okay, that'll make you understand exactly where the fulcrum, resistance and the effort are within your different class lever systems. We're specifically going to have a look now at mechanical advantage. So we've already had a look at a video and a PowerPoint. This is now going to be a bit of a challenge for you. I'm going to show you a bit of an experiment as to why you have a mechanical advantage for strength and why you have a mechanical advantage for speed in two different lever systems. Now for strength, you're having a look at the class 2 lever system. Okay, so the one in your ankle, for example. Okay, that's the class 2 lever system. That has a mechanical advantage for strength. Okay, so the first one we're going to have a look at then is mechanical advantage for strength. So if I try and lift this resistance here, or load, okay, using one finger, okay, with a long resistance arm and a short effort arm, okay, I really have to push down hard. Okay, that's one finger that I'm using and I'm really straining that finger. I'd be more comfortable with probably 4 fingers just pushing down. Okay, so I'm really having to strain, put a lot of effort into that. So there's a lot of force having to be created just to lift that load. Now if all of a sudden what I do is I now reduce that resistance arm. So now the effort arm is now longer than the resistance arm. Okay, the effort arm is longer than the resistance arm. So what happens now is I find that with one finger I can easily, okay, lift that, or can easily counterbalance it. Okay, so if you have a longer effort arm than you do have a resistance arm, okay, then you have a mechanical advantage of strength. You'll see this mechanical advantage in a class 2 lever system where the resistance arm is longer than the effort arm. Okay, now what I'm going to change up now is we're going to have a look at mechanical advantage for speed. So I'm not going to tell you the answer to this. This is going to be a bit of a one where you're going to try and figure it out and you're going to try and answer the question. I'm just going to show you 2 different sort of little experiments. I need to propel this resistance or this block as high as I possibly can, or as far as I possibly can. Alright? Okay, so what I'm going to do is I'm just going to use some force. Okay, I'm going to use the same force. I'm going to push down as hard, okay, this time as I will for the next part of the experiment. Okay, so from there, ready? Okay, so as you can see, the block or the resistance didn't go very high, so I'll do it one more time. Okay. Now, if we have a look, all of a sudden now, I'm going to use the same force, okay, to push down. All right, and we're going to have a look and see what happens to the block. Okay. Extreme experiments. Okay, as you would have seen, that actually went over my head, all right, and landed on the floor beside me. Now, my question to you is, why, with the same amount of force here, why did that block all of a sudden, instead of just going up by about 1 inch, which it did for when the effort arm was longer, why is it all of a sudden now flown over my head? Okay, remember, you've got from the fulcrum to where the force is applied is your effort arm. From the fulcrum to the resistance, okay, where the weight is, and the most of the weight, the mass is, okay, that is your resistance arm. All right, have fun with that.